So if we've got this exploding multiplicative cases where each time we have a corner case or even any kind of branch, we multiply it with the other branches, it seems like our software would explode with complexity and we'd just never get out of it. So how do we? My name is Eric Normand, and these are my thoughts on functional programming. So one way I want to talk about today that we can handle this complexity, at least limit it somehow, is by using a case, a limited number of cases. So if you have some function that, let's say, has 7 different cases, it has a branch in it, it's got 7 different cases, and who knows what happens in each of those branches, right? Because each branch could have 3-4 cases itself, because it calls another function that has branches in it. How do we ever deal with the complexity at all if that's what's happening? You have this giant tree of branches, and one of those branches is going to execute and it's going to have our answer. Well, the answer is that we limit the number of cases that we will return. Okay, so what that means is if you have 10 branches, you might say, well, there's only going to be 3 possibilities coming out of here. So each of those 10 branches has to return one of those 3 cases. And so in that way, you're taking this thing that could have, if you multiply it all out, it could have 20,000 branches, it could have 1,000 branches, and you're limiting it to 3 cases. So you've reduced the complexity by bucketing. You're bucketing all those different possibilities into a smaller number. And this is the kind of thing that a language like Haskell has an advantage for, because they have what are known as discriminated unions, also known as variants, where you define a new type that has different constructors. Each constructor is a different case that has the data required for that case. And so you have different ways of, an example is different ways of communicating with someone. So you might have communication method as a type. And then the 3 cases are email with a string. You have phone number with a string, which would represent the phone number. And then maybe you have their address, which is some other complex type that has like the street, the city, the state, the zip code, that kind of thing. So what you're doing is you're defining a limited set of ways to communicate with someone that your system can handle. And what that does is it means that no matter what branch you're on, you are going to get back a valid way to communicate with someone that your system knows how to handle. It could be at 20,000 branches, 20,000 different paths through your code to find an answer, but it's going to be one of those 3. And that's a powerful thing, that we should constantly be trying to rein in this complexity, because it happens, the complexity multiplies, and it multiplies too easily, right? Like without any work on our part. It's almost like entropy is on the side of complexity. And we need to put energy into bucketing those things and making decisions about which one of these 3 are we going to handle? And so when I see code, I often look at it in terms of how much complexity is this eliminating or creating, because very often it's just creating complexity. For example, there's a pattern that I think of as generating complexity, which is when a function returns different types and each type is supposed to mean something different. So it might return a string. Well, let's say in the case of well, I'll get to that later. Let me finish this example. So in the case, if we have different types, we might say, well, a string is going to be the name of the person, but if we don't know the name, we'll return nil. But maybe they have multiple names, so we'll return a list of names in that case. And now the problem is you've generated 3 cases, and one of them is super complex. The case where you return a list of names, now you're just opening up the door for complexity, because a list has this other problem, which is it can be empty, and that's a case that you might not have thought about. And you also have the case of like, well, what do you do with all those extra names, right? You're just passing on the decision to some other piece of code. And so then that code has to have branches, has to have all 3 of these branches, again, the string, the nil, and the list, and it has to figure out what to do with it. And so what you want to do is think about whether you can reduce this, and just go through each one and say, well, nil is obviously not good enough as an answer to cover all 3 cases. It's not. I mean, you can't represent anything with nil. A string might be, you could say, well, if we don't know the name, we'll return an empty string, or we'll return something like unknown name, right, or anonymous, something like that, or whatever fits the software. And then if they have multiple names, well, we could just say, well, we're just going to pick one now. We're going to pick the first one. So maybe a string will work, and that might be a really good answer. And then you could also say, well, the list of names can work for everything, because we can have 0 names if they don't have a name, so an empty list. We can have 1 name, which is the other string case, and then we can have multiple names if that's what we want. And so the list also works as a single case to eliminate this complexity. You still might have to deal with the 0 names and the 1 name and the multiple names as separate cases, but those are kind of implied by the list already. So you'll probably be aware of that when you're writing your code, and so you won't get mixed up. And also, maybe what you want is to turn the singular or the plural into a single thing, which is potentially plural, but it's a list, because you want to iterate through it, or you want to do something else that's list-like. And that really depends on your use case. But you see what I've done is I've taken these 3 possible cases and I've turned them into 1 in 2 different ways. I eliminated nil. It's not going to work. If I just need a string to print to the user, maybe no name is the best string, or an empty string is what you should write. And so why don't I just return that? So, I mean, deciding between whether you have a string or a list, that is actually up to your application and like what you're going to do with that. But that's the kind of analysis I do. When I see someone returning different things, I'm like, just pick one and just make that make that one case, eliminate some complexity there, because you're going to have to use that somewhere else and have those same 3 cases, pick apart your value and figure out what branch it was on over there. So you've coupled the 2 implementations. Okay, another thing I see is something like, in the case that we had before, where you had like a string for the email address and also a string for the phone number, right? I see people using the string and returning just the string. Like, let's say you had those 2 cases, a email and a phone number. They'll just return a string with the value in it, and then later in some other code, they have to use a regex or something to figure out what type of thing it is. And that sucks because it's probably not the responsibility at that point where the regex is to know like what are the possible things that this thing can return, right? And so what you want is some way to capture what that is, what the thing is, outside of the string itself. I mean, there's probably no overlap between emails and phone numbers, but it probably does get kind of complicated. Like, what if someone wants to be, like, what if you have, let's say you have email and text message, right? So that sounds like an email address and phone number, but now you're going to support Apple Messages, which you can use an email address to address someone. Now you've lost it. You don't know what's what anymore just by using a regex. And so what you should have had is some way of tagging that value as for what it is. And so you don't have to do the regex anymore. Just you might still have to do the regex for some other reason, like validating it, but you don't have to do it to determine what case you are in. You can use the tag, which should be well known, and maybe even you have compiler help to make sure that you're getting all the tags like you would in Haskell. And so that tag, if there's a very limited amount of information, I would use a tuple. So in Haskell, I would use a dedicated type with different cases. But in Clojure, I would use a tuple, and the tuple would have the first element of the tuple would be the tag as a keyword. And so I would put email and then the string. And then if I was doing a phone number, it would be like phone number string. So the keyword phone number and then the string with the phone number in it. And that you still need to know somewhere else that there are 2 cases, right? It doesn't eliminate that problem. But, well, I mean, you might not, because you can wrap that up, right? You can wrap that up in an API, in a set of operations that are valid on communication methods. Okay, so you can have a set of functions that have the cases, but that's all implementation that's hidden behind the interface. And that's another issue which I see a lot, which is people just putting stuff in a map. And maps are great, like you should put stuff in a map, but you should also define an interface for it and wrap it up. Like, you shouldn't just say someone else has to know the structure of this, because now you're coupling the thing that is consuming the map with the thing that produces the map. And so you shouldn't, some other piece of code shouldn't have to know the exact structure of the data that you're returning. It should be wrapped up in an interface. And that's all about eliminating complexity. Okay. I think I've teased that idea of wrapping stuff up in an interface. We'll talk more about that at a different time. Awesome. Thank you so much. Please subscribe, like, star, +1, all those things. You know, they really help people find this. And if it could be useful to people, I hope that people do find it. And you're the ones who have already found it, and maybe you think it is worth finding. So please share it with people. Also, I've been getting lots of cool comments on Twitter, by email. My Twitter is Eric Normand, and my email is eric@lispcast.com. Please, whatever you think, if you agree, if you disagree, I would really love to have a discussion with you. That's what this is all about. All right, great. See you later.